Welcome back to the second part of our discussion of problem solving, a topic in the course Mathematics in the Modern World. Last time, we discussed about Polya's four steps in solving problems. They are the following: understand the problem, devise a plan, carry out the plan, and review the solution. We are going to apply all these four in solving problems by working backwards. Solving problems by working backwards is much like losing your personal possession. For example, you lost your phone. What are you going to do? The natural thing to do is to go back to places where you remember still holding your phone. Solving problems by working backwards works the same way. If the problem has procedures, we trace back these procedures to find the answer to our problem. Let's illustrate this with 3 examples. First example: Naruto, Sasuke, and Sakura collect coins. They exchange coins among themselves according to the following arrangement. Naruto gives Sasuke as many coins as Sasuke has, and Sakura as many coins as Sakura has. After that, Sasuke gives Naruto and Sakura as many coins as each of them has. And then Sakura gives Naruto and Sasuke as many coins as each has. If each finally has 256 coins, how many coins do they have originally? Let's first understand the problem. First, these two sentences tells us that there are 3 people in our problem that likes to collect coins, and that they like to exchange coins as well, or they will exchange coins as well. This next sentence tells us that Naruto will give Sasuke as many coins as Sasuke has. Let's pause for a while. What does this statement mean? This means that if Sasuke has 50 coins, then Naruto will also give Sasuke 50 coins. That means, if Naruto has 500 coins, he will now have 450 coins after giving Sasuke 50 coins, and Sasuke will now have 100 coins. Let's go back to the problem. If Naruto will give Sasuke as many coins as Sasuke has, and Sakura as many coins as Sakura has, then if Naruto will give Sakura 100 coins, then Sakura will have 200 coins if she has 100 coins to begin with, and Naruto will now lose 150 coins, 50 after giving Sasuke 50, and 100 after giving Sakura 100. So if Naruto originally has 500, then he will now have 500 minus 150, which is 350 coins. Going over the next set of sentences tells us that they will do the same thing as the previous sentence. And finally, at the end, they will have 250 coins. Let's use Microsoft Excel to write down the given. Well, first, Naruto will give Sasuke and Sakura coins. After that, Sasuke will give Naruto and Sakura coins. And finally, it's Sakura's turn. We'll give Naruto and Sasuke coins. And at the end, they each have 256 coins. And the question is that how many coins do they have at the start. So these are all the given in our problem. So our strategy, now that we understood the problem, we can now devise a strategy. Our strategy is to work backwards, meaning we will start here at the end, in which they have 256 coins, and then follow these procedures until we figure out their original number of coins. So let's write down the names here: Naruto, Sasuke, and Sakura. And then let's write here on the left column the process that we will trace. So at the end, we know that they have 256 coins. Next, we write down what happens before they had 256 coins each. Well, what happened is that Sakura gave coins. After Sakura gave coins, or before Sakura gave coins, not after. Because after Sakura gave coins, this is the end already. So let's figure out how much do they have before Sakura gave coins. Well, we know that this number is doubled because Sakura gave Naruto as many coins as he has. So we should divide this number by 2. And we get 128. Similarly, we will divide Sasuke's coins by 2. And we should also get 128. So meaning, before Sakura gave coins to Naruto and Sasuke, she has 128 plus 128 plus 256. So let's write it down. 256 plus 128 plus 128. Next, we figure out how much coins do they have before Sasuke gave coins. Okay, so before Sasuke gave coins, this number is half. So let's divide this by 2, and it should be 64. Similarly, we should divide this 512 into 2, and it should be 256. Meaning, since Sasuke gave Naruto 64 and Sakura 256, then Sasuke should have 64 plus 128 plus 256. Meaning, before Sasuke gave coins, Sasuke has 448 coins. Finally, before Naruto gave coins, this is now the original number of coins that they have at the start. So original number. So he gave Sasuke as many coins as he has, so we will divide this by 2. He also gave Sakura as many coins as she has, so we will divide also this by 2. And so, the number of coins Naruto originally has is 64 plus the 224 given to Sasuke and the 128 given to Sakura. So therefore, our conclusion is that they originally have 416, 224, and 128 coins, respectively. Let's proceed to our next problem. Kim bought some rabbits in June. She had 4 times as many rabbits by the end of July. she had 46 rabbits by the end of September, which is 10 more rabbits than she has at the end of July. How many rabbits did she buy in June? Oh, before answering this problem, let's look back in our problem number 1 since we forgot to look back. Well, looking back, we know that if Naruto will give Sasuke and Sakura coins, as many as they have, then this number will be doubled. So 224 will be doubled, and that's 448. And 128 will be doubled, and that's 256. And then subtracting 224 and 128 to 416, we know that we should get 64. And Sasuke will now give coins. So Sasuke will double this number, and it's going to be 128. And Sasuke will double this number, and it's going to be 512. And subtracting 64 and 256 to 448, from 448, we're going to get 128. And finally, Sakura will give Naruto and Sasuke each 128, so it's going to be 256. So in the end, they all have 256, and our answer is now correct. So, going back to example number 2, we have a rabbit problem. So, let's try to understand this question. So first, we have a rabbit lover named Kim, and she bought some rabbits in June. So she had 4 times as many rabbits by the end of July. What does this mean is that if she bought 10 in June, at the end of July, she had 4 times of 10. So it's going to be 40. So that's just an example. Let's continue. She had 46 rabbits by the end of September, which is 10 more rabbits than she has at the end of July. So meaning, if at the end of July, if at the end of September, she had 46, and that's 10 more than the end of July, then July must be 36, right? And the question is, how many rabbits did she buy in June? So we again use our Excel file to solve this problem. So what we know is that Kim bought some rabbits in June. That's what we know. And then by July, the number is 4 times the number of rabbits in June. And by September, this number is 46, which is 10 more than the number of rabbits last July. And our question is, how many rabbits did she bought last June? So that is our problem. And again, we are going to work backwards, right? So let's try to write the end here. And how many rabbits did she had at the end? Well, the end, which means September, she had 46, right? And then this sentence here, this is the first step. The number in September, which is 46, is 10 more than the number of rabbits in July. So meaning, at the end of July, the number is 36, which is 10 less than the number in September. And then, by July, the number is 4 times the number of rabbits in June. So meaning, the number of rabbits in June is divided by 4, 36 divided by 4, which is 9. So therefore, our conclusion is that she bought 9 rabbits. And then looking back to our solution, if she bought some rabbits in June, then at the end of July, 9 times 4 is 36. And then by September, 36 plus 10 is 46. So our answer is she originally bought 9 rabbits. For our final question, we have this problem. Ramon bought some boxes of knives to sell at a market. He sold half of the boxes to the first customer and he gave an extra half of a box. He sold half of the remaining boxes to the second customer and also gave half of a box. The same thing for the third customer, and Ramon has no more boxes of knives. How many boxes of knives did Ramon bring to sell in the beginning? So let's try to understand some problem. We try to understand the problem. So Ramon has some knives and he's going to sell it at the market. And then the first thing that his first customer bought half of all the boxes that he has, and then he gave an extra box. And then the same thing for the third customer. And then the question is that how many boxes of knives did Ramon bring to sell in the beginning? So again, let's use our Excel, our very handy Excel, to solve this problem. So let's write down what we know. Ramon has some knives, some boxes of knives. That's what we know. He sold half of the number of boxes and half a box, and gave away half a box, half of a box. Let's correct it down. Let's correct that. Half of a box. He did the same on the second customer. So he did the same. So he sold half of the remaining number of boxes. Remaining number. Let's correct the grammar here. Yeah, okay. So he sold half of the remaining number of boxes and gave away half of a box again. And finally, he did this again. And the ending is that no box left over. No box left over. So, and the question is that how many box does he have originally? Okay, so let's again work backwards. At the end, he has no box, right? 0 here. Next, let's trace our steps. So the last thing that happened before he has no box left over is he gave away half a box. So before giving away half of a box, then before selling half of the remaining box. So since the opposite of selling half is doubling, so we're going to double 0.5, which is going to be 1. So we're done with this part here. Next is that he next gave away half a box, so we add 0.5 in this one. So before giving away half of a box, so maybe we can write here to the third customer, before selling half to the third customer. This is still the third customer. And then before giving away half of a box to the second customer. So half of a box means 0.5 will be added to 1, so that's 1.5. And then before giving before selling half of the box to the second customer, that's the second customer, we will double 1.5, that's 3. And now we are here at the first customer. So before giving away half of the box to the first customer, he has 3.5, right? And then he has half, right? He sold half of the box, so half of the remaining before selling half of the box, half of the number of box to the first customer, so he must have double of 3.5, which is 7, right? So therefore our conclusion is that originally he has 7 boxes. Let's try to check if our answer is correct. So Ramon has some boxes, that's 7. So he sold half to the first customer, and then comes 3. So, and then selling half of it, so it's 1.5, and then give away 0.5, so it becomes 1. And then sell again half, or maybe let's do it here. So Ramon has some number of boxes, 7. So he sold half of 7, so it's 3.5. But then again, he gave 0.5, so it is equal to 3, correct? Yeah. And then he sold half of 3.5, so that's 1.5, but minus 0.5, so it gives you a 1, right? And then sold half, which is 0.5, then minus 0.5, you'll get 0. So our answer is correct. We have many more examples for you. We want you to check it out and then comment or ask your teachers questions if you did not understand the problem. So we have 3 more problems that you can solve by working backwards. This is problem number 4. This is problem number 5. It's a Monopoly game, if you're familiar with Monopoly. And then finally, this problem number 6. So our next session will be solving problems by looking for a pattern. And see you then.